Hi there. Thanks for joining us. This is Space Nuts. Andrew Dunkley here. Great to have your company. This is a Q&A edition, which means we don't have to do anything because the audience provides all the content. We just have to try and figure out what they want to know. We have a follow-up from RK in Sweden about space and time. Apparently, we tried to tackle this question at the end of last year. We promised to review it in January. It's now almost April. We forgot, but he sent us a gentle reminder. So we'll see if we can handle that one. John is looking at the inherent direction of object movement in space. David has some thoughts on the Osiris Rex mission. Baloo has a hypothetical for you, Fred. And if we got anything else we can throw into the mix, we will do so on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
As much as he hates it, he's back again. Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Yes, I am here.
Yeah,
Well, bits of me are.
Yeah,
The few minutes that's left.
I know you love it, especially the Q&A. It's always good. Some of these questions are incredible today, so we'll enjoy those. And Heidi Campo is with us on a very steep learning curve into a black hole called Space Nuts. And welcome, Heidi.
Thank you so much.
Actually, what I just said probably does relate to the very first question, which has come from RK in Sweden. He said, this is a very long read, so sit back, relax, get comfortable. In episode 408 in December, I asked a question about if space and time can switch roles inside the event horizon of our black hole, in brackets. More specifically, does time and space switch roles the moment you pass the event horizon? If so, does that mean that that space can go in only one direction, towards the center of a black hole, hence the reason why nothing can get out? Does it also mean that time can go in any direction inside the event horizon? In episode 504, you also mentioned that arrows of time might not be what we previously have thought. You didn't have an answer straight out in December's episode and promised to come back to me mid-January. Otherwise, you asked me to remind you. Then I guess space and time got switched for Fred, and instead of replying in January, he physically ended up in the Northern Hemisphere, not far from where I live. I almost expected him to personally deliver the answer. That would have been nice anyway. Great show, and I hope you'll continue until the end of time or space. Clear skies, RK. Fred, you sent me this amazing video, which was on Reddit, explaining space-time, and it's about 12 minutes. I watched the whole thing and I got off to a great start, and then my brain just sort of imploded and melted down. But what I got out of it was that space and time operate in zero gravity, as you would expect, but as big objects start to disturb them, things change. And then you get to a black hole, and that's where everything goes upside down. So RK is probably kind of on the money there.
Yes, that's correct. His question was well formulated. There's never any doubt about that, because we do know that the roles of space and time they interchange within the black hole. The question that RK was asking was why is it so?
Yeah.
Why does this happen? And I sort of knew the physics, I guess, in a hand-waving way, but I looked for something that would explain it in as what I thought was as concise a way as possible, and came across this video, which you've watched, and I'm sorry it lost you halfway through, but keep watching, because it is very clear as to what's happening.
Yeah.
And we should credit the author of this video, whose name is Alessandro Roussel, and you can find it. It was the Reddit discussion is where, exactly as you said, where it turned up. RK, have a look at this. It's called "Why Time and Space Flip Inside a Black Hole." As Andrew said, it's a 12-minute video. It is very, very well done.
Yeah, it's on the, just so I can get it through to him quick before I forget, it's on the physics subreddit. So,
okay.
Yeah.
Right. Okay. I'm not a Reddit person, so I wasn't aware of that, but I did see physics there.
Yeah.
So it comes about because of this relativistic concept of light cones. The fact that if you look at a four-dimensional space, in order to get this into your head, you've got to collapse it to three dimensions so that the three dimensions of space are squashed into a plane, and the other dimension is time. Then it's part and parcel of the way relativity works that there's what's called a light cone, which is effectively a 45-degree angle cone, which is on the inside of the cone are things that you can see because their light will reach you as an observer. On the outside of the cone, the stuff that you'll never see because its light will never get to you. And that's the bottom line. I'm not really explaining this very well. It needs a diagram, and the video is replete with moving diagrams, which I think explain it. The bottom line of this is that as you approach a black hole, you are in a regime where the space is highly, highly curved. I'm sorry, there's something going on outside my window. Which
sounded like a cockatoo.
It was three kookaburras passing over a scrap of meat, and then they were dispersed by young Geordie there, who decided to come and join in. So if anything really exciting happens, I'll turn my laptop around and you can watch it live, but it's not that good at the moment. Sorry. As you get near a black hole, you are, because of the fact that we know space distorts in the presence of mass, with a black hole, that distortion is extreme. The theory of relativity is what allows us to understand the distortion of space, but the particular case of a very small singularity, in fact, a point with zero dimensions, distorting space, that it was analyzed not by Einstein, but by his colleague Schwarzschild, just after Einstein published his relativity theory. And that tells you that the space is highly curved around a black hole. And what that means is your light cone gets bent, basically. It bends towards the black hole. And the time dimension of the light cone actually becomes space, effectively, because it's pointing towards the black hole. It's the twisting of space and time that results in that interchange between space and time. I haven't explained it well. That little video, Alessandro's video, I think is pretty well as good as it gets in trying to explain this without immersing yourself in some horrendous mathematics.
Yeah, the video gives an example of an astronaut falling into a black hole, and once you pass the event horizon, everything turns upside down, and you're just being sort of drawn to the center of the black hole. Space and time flip, basically.
Yes. That's right. It's an angle, almost an angle thing.
Yeah.
Alessandro did resist the temptation to depict the astronaut being spaghettified, which would have probably not been.
It's almost like depicting falling into the upside down in the TV show Stranger Things.
Yeah, more or less. That would. Yeah, I've seen that series and I know what you're talking about. So yes, Fred probably hasn't.
I haven't. No.
He has much more eclectic taste than I have, but we often share notes on TV shows and movies, and of course, your podcast about science fiction, whether or not it could happen in real life, is a great listen. And I've listened to a couple of episodes, and the people you get on there are fantastic, Heidi. And yeah, it's interesting how sci-fi has kind of worked its way into real life, and not the other way around sometimes. So. Yeah, it's a really interesting sort of a pseudoscience type of thing.
Here's a side tangent with that. I was interviewing some spacesuit engineer recently, and she was telling me an interesting factoid that the first model spacesuits, they painted them silver, not for any benefit to the astronauts, but because that's what sci-fi depicted spacesuits as. So they thought, well, we need to make it look like a spacesuit. And so there are so many cases where science fiction influences the science that we're actually doing. And that's just one funny example.
Yeah, I didn't know that. That's an absolute ripper. That would have made a great radio question back when I was on the radio. Yeah, used to love doing all that sort of stuff. But yeah, that's what I might do for Archie is if I can find his email, I'll email him the link to the video.
That would be great.
In fact, Hugh, if he hears this part of the podcast, might want to put that on the show notes so I can that might be a way around it as well. But Archie, thanks for the question. Hope we adequately answered it. We strive for adequacy here on Space Nuts.
0G, and I feel fine.
Space Nuts.
Now, to an audio question, here's John.
This is John from Foster, and I have a question regarding the movement of objects in the universe. It appears to me that most objects in the universe have some form of rotation or movement, either the rotation of a planet or a moon on its axis, or the orbit of the moon around its planet, the orbit of a planet around a star, and the rotation of galaxies. Now, save for those circumstances where an object is tidally locked due to gravity, and some exceptions for certain reasons which you might be able to explain. My question is there an inherent direction of movement and rotation, much like the Coriolis effect on weather and water on Earth, that applies to celestial bodies? In other words, do bodies inherently spin in a certain direction? Do planets inherently orbit in a certain direction? And do galaxies spin in a certain direction? And if so, why? And if not, why not? Thank you.
Okay. Thank you, John. Hope you're well in Foster. Heidi, Foster is one of the most horrible places in the world. I would never live. Horrible, dreadful. No, it's beautiful. Absolutely beautiful up there on the mid-north coast of New South Wales. Yeah, very popular holiday spot. Is there an inherent direction that objects move in space? If so, why? And the direction I think he's talking about is that away. That away would be the simple answer, but I think you probably know a bit more about it than I do, Fred.
If you were pointing east, Andrew.
I wasn't.
No.
I am now.
Right. That's the way you're moving because of the Earth's rotation. And you're doing roughly 1,400 kilometers an hour eastwards. So hang on.
And look at my hair. It's not even moving.
Anyway, look, there's a number of layers to this question. It's a great question, John, and you've actually touched on something that's right at the cutting edge of research. But the one thing that's not really at the cutting edge of research is why planets in a solar system like ours all do have a preferred direction of not just revolution around the sun, but rotation about their axes. So if you sit at above the North Pole of the Earth and look down at the Earth and the whole solar system, virtually everything is rotating anti-clockwise. Not everything. There are one or two things that don't fit the picture, but when you generalize it, the planets are all moving anti-clockwise. Most of them are rotating anti-clockwise. Their moons are going around in orbit anti-clockwise. The whole thing is, it's an anti-clockwise dominated environment. And that's because of the way all this stuff has been formed. Because originally, it was part of a disk of material that was going, guess what, anti-clockwise around the baby sun. The sun's formation involved the collapse of a cloud of gas and dust. The central part got hot enough to start nuclear fusion reactions, and the rest of it formed into this disk, the protoplanetary disk we talked about in the last episode. And there are moons forming in that as well. And certainly in the case of the solar system, everything's going anti-clockwise. So that's to do with the way it was formed. And it's likely that the rotation of galaxies is like that too, that you might well find that a galaxy originally collapsed from a very much larger cloud of gas, probably gas because these happened earlier. There would probably not be that much dust around at the time, although there's some there. That gas cloud would have an inherent rotation, which probably would have come just from a prevalence. There would have been, in a static gas cloud, there are going to be eddies forming. And as this thing collapses, those eddies kind of basically, there's an election, and the most common direction of eddying is what ends up being the rotation of the gas cloud as a whole. And so that's probably why galaxies are rotating. But the reason why I think you've put your finger on something very new, John, is that there was a study I read. I didn't really read it in detail, and I've yet to go back to it, but it was some results that came out, I think about a fortnight ago, that suggests that when you look at the very distant universe, there is a prevalent direction of rotation of galaxies. And it's, they're all at different angles, but it looked as though, from our perspective, an anti-clockwise rotation was more prevalent than a clockwise rotation. I think that's right, rather than the other way around. Can't remember. Might have been the other way around. Doesn't matter. The bottom line is that there seems to be a preferred direction of rotation, and that flies in the face of what we understand about the way galaxies form. We think there should be no preferred direction of rotation. And so there may be new results coming from that too. And I should have read it in more detail if I'd known John's question was coming, but I will have a look at it and see if there's anything more to add to that story.
We do see variations which are circumstantial even in our solar system. When you've got Venus, is it Venus that spins the wrong way? And and Uranus is on its side and spins the wrong way and all that. So, and there are a few moons that go the wrong way around because they've been captured rather than formed in situ. So there are, yes, you're absolutely right. There are misfits, but we can understand the reason why they're there. The overall rotation is due. The big picture, everything's pretty well doing the same kind of thing.
Quite so.
And did we figure out why?
Yes. We did.
Good. I was listening. I was always listening. Yeah.
It's the rotation of the protoplanetary disk, Andrew.
Yes, that's it. I knew that. I heard you say that. It just went like, straight through.
Went clockwise right through your head.
My head's in vacation mode. That's what's going on.
I can tell.
Yeah. So the answer is yes, because, John?
But it may be yes because we don't know as well with the big picture stuff. So that's
fair enough.
Program.
Thanks, John. Hope all is well in that dreadful corner of the world called Foster. This is Space Nuts. Andrew Dunkley here with Fred Watson and Heidi Campo.
3, 2, 1.
Space Nuts.
And our next question comes from David. David's in Indiana. NASA's Osiris Rex mission returned with a sample of the asteroid Bennu. The announced testing results just released are interesting, or interestingly close to our planet's makeup. It starts me wondering, with Bennu's proximity, so close to Earth, could it have been a satellite of ours, or possibly ejected from a collision with another solar object like Theia, which you've already mentioned? Greatly enjoy the podcast. Dave in Westfield, Indiana. Dave, if you were in Westfield in Australia, you'd be living in a shopping mall. But that's a different story.
There's Westfields all over the world, Andrew. So
maybe so.
Yeah. It's probably not is the answer to that. It probably didn't form as something that was knocked off the Earth. because its composition, yes, there's a lot of similarities, but I think people who know much more about asteroid origins than I do, bye Heidi.
Yeah, she's dropped out. Something must have happened, but
I think so. Would say the evidence seems to be that there was a collision, but it wasn't involving the Earth. It was a much larger asteroid, carbon rich probably, like Bennu is, and that it probably happened, within the last billion to 2 billion years, and it formed in the main asteroid belt. And probably that collision is what sent it to interact much more closely with our own planet. So it seems unlikely, despite the similarities, which I agree with you, there are similarities in composition, but it may well be that that's just, circumstantial, and it might be because the Earth basically came from the asteroid belt. At least it came from the same protoplanetary cloud.
Yeah, absolutely. And yet we do see variations like Theia hit the Earth and we've got the moon.
Yeah.
But there's stuff on the moon that you can't find easily on Earth, and there's more of it. And, there are differences.
Some of that stuff's more recent, though. That it's because of the interaction between the moon and the solar radiation. Things like helium-3, which is much more common on the moon than it is on Earth. But the rocks of the moon are basically the same as the rocks of the Earth, with a similar isotopic composition.
Just boring old basalt.
A lot of it is, yeah.
Yeah. But you find that stuff everywhere.
Oh, yes. Yeah.
Okay, so there you are, David. Probably not is the answer. Our final, sort of question. It's a question from Baloo, who's sent questions in before. This is a hypothetical for you, Fred. Are you ready? Are you ready, Freddie? Here we go.
Baloo here again from Fayetteville, North Carolina. Would you rather be a scientist with nothing left to solve, nothing left to discover, or a scientist and everything that you try to invent, discover, figure out is wrong? It's just always wrong. You never get any headway. Thanks. Hope to hear y'all's answers. May the force be with y'all. Have a great one.
Thanks, Baloo. I think most scientists are option 2, aren't they?
Yeah, well, I certainly am. Yes. Yeah. Yeah, and to be honest, I'd rather be one. I'd rather be that than somebody who's solved everything, because the odds are, if you thought you'd solved everything, you haven't, because most science actually digs up more science. It's all about, discovery always raises more questions than it answers, and so it looks as though all knowledge is not something we will ever achieve. And there's trying to think, is that Gödel's theorem that we can never know everything? I can't remember the details. I think it is. I think it's Gödel's theorem that whatever we discover, there'll be something else left to discover. It's a mathematical hypothesis. So yes, we may well never know the answer to everything. And that's good, because it means scientists will always have a job.
Yeah, Gödel's incompleteness theorems, 2 theorems of mathematical logic that are concerned with the limits of probability in formal axiomatic theories.
Yep, that's right.
Yeah.
Just as you said.
It says they're widely but not universally interpreted as showing that Hilbert's program to find a complete and consistent set of axioms for all mathematics is impossible.
There you go.
Yeah, that's another one that makes your head hurt. But when you get down to the bottom line, it makes sense that we could never solve everything. And once you solve something, it's like astronomy. Once you've found something that answers a question, you find yourself with another array of questions. Yeah. It's just ongoing. And look, what would humans be without the need to discover? If everything was solved, we'd get bored real quick.
I think we would. Yes. I think we would. You're right.
Yeah, it wouldn't be fun anymore. And mysteries are good to have because it just keeps you motivated to try and solve problems. And yeah, we don't want to solve everything. Well, I suppose we do, but that's what drives us, I would suggest. Have you got time for one more without notice, Fred?
Yeah.
Yeah, let's do it. This one comes from Robert.
Hello, Fred and Andrew. This is Robert from the Netherlands. I have a question for the professor about the discovery of exoplanets. Because I'm not sure if the same configuration as our own solar system, and what for inner rocky planets and for our gas giants, if that configuration is unique or not. As you know, there's been a lot of discoveries of these planetary systems, but not to send the tale of the continuous solar system, of course. I was just curious if we are very unique or not. Thank you so much for taking time. Bye-bye.
Thank you, Robert. This is a question we've had previously, but it's a good one to revisit. I think we did talk about it fairly recently, but is our solar system, the way it's set up, rocky, gas, unique? And the answer is mostly yes, isn't it?
Well, it's unique in the sense that
so far.
Yes, so far, that's right. And it is unlike most of the other things that we find, but some of that might be due to the fact that we've got what we call selection effects. You know, that you can't really see everything when we look out at the exoplanet. So there may well be systems where there are planets, 4 rocky planets at the sort of distance that ours has, which are actually really hard to discover. They're the ones that are the most difficult to discover. So the easiest things to discover are massive things like Jupiter or bigger than Jupiter. We are pushing down the mass spectrum towards the more, the smaller bodies of equivalent to the rocky planets in our solar system, but it's still, nevertheless, ours is a very special case because we can see it in detail, and we haven't really seen anything like it, but it doesn't necessarily mean that there isn't anything out there that's like it. So we may not be unique. We might just be unique in as much as what's been discovered so far.
Yeah, that makes sense. And given how many systems exist out there, I'd be very surprised if we don't find multiple solar systems like ours in time to come. So at the moment, Robert, it looks that way, but ultimately probably not, I think would be the short answer. Thanks, Robert. Thanks, Baloo, David, John, Aki, for sending in your questions. Much appreciated. And of course, if you have a question for us, please send it in to Space Nuts via our website. Just click on the AMA link at the top, spacenutspodcast.com, spacenuts.io. And that's it for me for probably the next 8 or so episodes. Judy and I are taking a little sojourn. We're going to cruise the Panama Canal and visit a few countries along the way. I'll be back late April, but Fred will be in the capable hands of Heidi Campo, who had to exit early. I think her dog was getting hungry, and you never say no to a dog. But Heidi will be looking after everything with the cooperation of one Hugh in the studio. And Fred, thank you so much. I really appreciate it, and I'll see you in about a month.
I'll look forward to that, Andrew. I hope you have a great time. Just watch out for the Panama Canal. It's not very wide.
Yeah. I don't know I don't know which way we're going into it, but we end up in Panama City for a couple of days, which we're going to enjoy. But we're actually going to do a full-on proper Panama Canal tour because I want to understand it more. I've heard so much about it through my entire life, and I think it's going to be really interesting to just understand it more and find out everything about it. But yeah, that'll be fun. So thanks, Fred. We'll see you soon, and thanks to Heidi for stepping in. Thanks to Hugh in the studio, who couldn't be with us today because he's hypothetical. And from me, Andrew Dunkley, thanks for your company. See you real soon on another episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.